If you have deployed a gateway API and it's working, this video is about what happens after that. Because most gateway API setups works perfectly until a request hits your system that was never designed to handle. So let me show you the kind of request that breaks most tutorial gateway. So here I'm doing the post request. So this payload is far larger than what this API should ever accept. And this is the larger file which I'm using to do a post request here. So here you can see I got a response that is 413. That 413 response isn't coming from the application. The request was rejected at the gateway before it ever reached the pod. This is the difference between the tutorial gateway API setup and the production gateway API setup. Today I will show you the 3 most common mistakes people make and how real team fixes it. Don't worry if it feels a bit fast right now, that's okay. We are going to slow it down. First we will understand the problem. Then I will show you how this particular system has been built from the scratch. So let's start with the first mistake. So most people start like this. If I do ls here, everything is mixed together. It works for demo, but it fails in the production. Before security, before performance, structure matters a lot. So let me show you how real teams organize gateway API. So I have a folder called K8s. In this folder I have all the files segregated into different sections. So if I run tree K8s, so you can see a folder structure here. So this is the heart of the production setup. So we separate what is common from what is environment specific. Here you can see the base folder. Base folder contains things that don't change like gateway, routes and the services. Below that we have an overlay folder. It controls the behavior like staging and prod, etc. Under the overlay, we have 2 folders. One is for the staging and another is for the prod. Staging is a lighter version and production is for the strict policies. It's having the same YAML files but having a different outcomes. Now the mistake number 2 is something I still see in the real production cluster. That is manual TLS. People generate certificate with OpenSSL, they copy private keys, they paste them into a Kubernetes secrets, and then everything breaks during the renewal. Let me show you what production TLS actually looks like. So here I am checking whether the certificate was issued automatically or not. So for that I have a cert-manager already installed in this particular system. If I run kubectl get certificate, so here we can see the certificate is already been created, and here if you see this is a secret section and under that we have a app-tls. This certificate is being created by the cert-manager. So this certificate was not created automatically. I didn't generated any key. I didn't pasted anything into the Kubernetes. The gateway declared the hostname, cert-manager handled the lifecycle, and then it talked to the Let's Encrypt and it issued the certificate. And that certificate becomes a Kubernetes secret. If you see here under the secret section, we have a secret called app-tls. And if I run kubectl get secret, so we can see this is the app-tls secret which is being created by the cert-manager itself, and it also has a certificate stored in it. So this secret is the final output. The gateway reads it automatically and HTTPS starts working. So there is no restarts, there is no reload scripts, but staging and production get separate certificates. If I try to access the application, so if I run kubectl get HTTP route to get the path of the application, if I copy this and run this, we can see that our application is working fine, and if we click here, it is secured. And this is backed by the cert-manager itself. If I see here, and we can see it's issued by the Let's Encrypt. So all this lifecycle is being handled by the cert-manager. So now our configuration is structured and our TLS is automated. But there is one more mistake that can still take your system down. That is unprotected gateway. Most of the time we expose the gateway and stop there only, but production platforms don't stop there. So for that we need to set up policies. So I will show you what we need to do to protect our gateway. If I come here and if I open this file that is under K8s folder, prod and the client settings. So this is a client setting policy. It controls how clients are allowed to talk to the gateway. If you see, this is the API version and this is the feature provided by the NGINX Gateway Fabric. If you see, this is the client, that is a client setting policy, and below that we have a metadata. Basically we are giving a name to this particular resource, and here is the specification, and under the specification you can see the target reference. This tells the gateway where these policies apply. Here we are attaching it to the HTTP route. There is no pods, there is no services. We are only attaching this particular policy to the HTTP route. So the routing and policy are cleanly separated in this. Below that you can see body, and under that we have a maximum size. So this defines the maximum request body size. Anything larger than 1 MB is rejected before it reaches the application. So this protects memory, CPU and the downstream services. So now let's apply this particular policy and test the large payload with this. So let me exit and run kubectl apply -f and this particular path. So the policy got created. If I run kubectl get client setting policy, its settings. So we can see the policy got created. So now let's test this with a large payload. So let me clear out the screen. So first of all, let me create one large file. So this is a command for the same. So it's creating a 2 MB file here. So we can see the file got created. So now let's do the API call to our endpoint using this particular file. So this is the command for the same. So I'm using a curl command. I'm doing the post operation to this particular endpoint, that is /API, along with the file which we just created, which is exceeding the policy which we just set. So let me press enter here. So we can see the gateway rejected this. The pod never saw this request. So there is no CPU spike, no memory pressure. So everything is under the control, because this never lands to our actual application. Gateway is the one who blocks it. Now let's send a valid request. So here let me paste this command. So here as well I'm doing the post request to this particular endpoint, but with a smaller data, and let me press enter here, and we can see it worked perfectly fine. So the valid traffic flows normally, only the bad traffic is blocked here. This is the real power of Gateway API. Developers don't need to write this logic. Security team don't need to touch the application code. The platform team enforces these rules consistently and in one place. With ingress, routing and behavior were mixed together. Gateway API separates routing from the policies. That separation is what makes this clean, predictable and production friendly. This is not a demo feature. This is how production platform protects services at scale. If you have made it this far, you are not just learning Gateway API anymore. You are starting to think like a platform engineer. In the next video, we will understand canary and the blue-green strategies in the Gateway API. If you found this helpful, hit like, share it with your friends and subscribe for more content like this. Thanks for watching. I will see you in the next one.